Thank you for joining us for this episode of Emerging Technology Horizons. I'm Mark Lewis, the Executive Director of NDIA's Emerging Technologies Institute. And in this episode, we have Ms. Nicole Petta joining us to talk about a wide variety of topics, mostly centered on microelectronics, which has been her passion for the past several years. Nicole is right now a Senior Director for Strategic Operations at Qualcomm, but she and I work together. Those of you following these podcasts will notice a theme, by the way, of folks that I got to work with in the Pentagon. But Nicole and I worked together in the office of the Undersecretary of Defense for Research and Engineering, where Nicole was the principal director for Microelectronics. It's a role that she began in December of 2018, and I will tell you that Nicole's impact on the Pentagon was just absolutely phenomenal. And she was the person who was leading the entire Department of Defense and mapping out the directions that we needed to go in the area of microelectronics. It was also of all the Department of Defense modernization priorities that were mostly derived from the National Defense Strategy from 2018. We had identified microelectronics as our top priority, or as I like to say, we loved all of our children the same, but microelectronics was maybe the child that we loved the most because it is so fundamental to everything that the department does. Current weapon systems, future weapon systems. I mean, anything. I think our mutual friend Mike Griffin used to joke that unless you buy a hammer at Home Depot, almost everything else you buy these days has microelectronics associated with it. And I'm pretty sure soon we'll be buying hammers with embedded chips as well. So that explanation will go. So Nicole, first of all, thank you so much for joining us on this episode. I'm looking forward to the discussion. If I could, let me start out by asking, what are the problems that we're facing right now in microelectronics, especially as they relate to the Department of Defense's use of microelectronics?
Sure. Thanks, Mark, for the opportunity to chat with you. It's always great to have that opportunity. The biggest issue really for the department is transitioning to the commercial curve and being able to stay on that commercial curve with advanced microelectronics. So, going back to the early 90s, the department adopted a trusted foundry model, which, when we were at 200 nanometer nodes, that was possible to kind of wall off your foundry behind security classifications and do everything really in a classified environment. As commercial industry has moved on to more advanced nodes, those techniques, the trusted foundry, are not necessarily compliant or compatible with commercial best practices. The foundries are multinational, as are the design teams. So what the department has done while I was there, and this had started previous to my being the principal director, was to shift from a perimeter approach, right, to a risk-based approach focused on the data that is inherent in the fabrication process and the design process. Where were things designed? Who designed it? Who touched it? All of the data that's in a foundry that exists for quality control, to capture that data and really look for anomalies that would indicate that there's an issue. And doing these processes that are compatible with commercial allows the department to actually get on that commercial curve and have the very best technology and stay on it.
So I know when we were working together, you often made the point to me that the trusted foundry model, although I always said, well-intentioned, created by well-meaning patriotic Americans, but in some cases it could actually have the opposite effect, that it could actually make things less secure. It could trick you into thinking you're more secure than you were. In some cases, opening us up to insider threats, or because we weren't using state-of-the-art components. That meant that peer competitors had more opportunity to get a hold of our systems, to analyze them, to figure out what they're doing. So is it? I know you've spent a lot of time thinking through the issues of trust versus zero trust, and you led in establishing principles of zero trust. Can you tell us a little bit more about zero trust and and what the origins are and how it relates to microelectronics?
Sure, absolutely. Zero trust is a concept that's applied to cyber security principles fundamentally. So it's not conceptually, it's not typically applied to microelectronics, but it is philosophically, what data are people accessing? What data do they need to access? How do I control that data? I don't, um, I won't blindly trust that this perimeter in my cyber system is not penetrable. I assume that everything is vulnerable and everything is being attacked. And so I carefully control who has access to the data and put up barriers and multiple barriers, right? And control the people, authentication, all these things. So if you think about it in terms of microelectronics, it's assurance based on zero trust principles, right? So I'm going to make decisions based on data rather than the perimeter, and if you think about cars, right? You don't blindly trust that your car is safe. There's all kinds of standards that exist, right? What
Yeah, yeah,
and there's no other aircraft. There's no other environment where we just blindly trust systems. But in microelectronics, we've fallen into that for whatever reason, and that is a vulnerability and a security risk.
absolutely, absolutely. And of course, moving to zero trust, as you said earlier, it gets us onto the commercial curve, which means the department is no longer buying components that are a generation or two behind the state of the art. What are our competitors doing, by the way? What do we know about peer competitors,
Yeah,
especially China?
our competitors are buying off the open market. They're buying what they like and what they want, and they're integrating those quickly into their systems.
So again, when you and I were both in the building, we knew that China was very aggressively building a microelectronics capability of their own. That's still very much the case. They're pretty open about it.
Yes.
Um, what keeps you awake at night in terms of competition with China?
Um, if we think about, Mark, the modernization priorities, at the base of almost all of those is your hardware and your silicon, right? I mean, if you're going to run AI software on top of old hardware, you're never going to have, right? You're never going to modernize those capabilities um, until the department figures out both how to get advanced electronics first and assure them, right? So the integrity and the confidentiality, and also how to get those out into systems that are both built and already out in the field. How do you rip and replace old technology and get new technology out? And then how do you integrate into future systems and update? I have a Tesla. I have a 2016 Tesla, and I get routine software updates, and there's an occasional chip update too that will come through. But that car is current with existing technologies. So you have to stay, you have to get these
Yeah,
microelectronics,
yeah.
and then you have to get them out, right? How are we going to get them out to systems, whether it's a ship or a plane? How do we get those advanced capabilities out to the warfighter?
Now I know you oversaw the creation of some very significant programs in the department. Many of those obviously have had staying power. They're still in existence with, despite the departure of both of us. You built this incredible alliance with the Office of Secretary of Defense, but especially the U.S. Navy and SWC Crane. They were kind enough to send the amazing Brett Hamilton
Yes.
to work in the Pentagon. I know he's been carrying on the efforts. Tell us a little bit about the programs that are in place now and where you see them going.
Sure. And I'll speak. I don't think anything has changed since I left, but I'm no longer in the know, so I'll speak
Yeah,
based on my
I know.
my previous role. So ramp is the first of the three, right? And ramp ramp really is, there's two objectives with ramp. One is to begin and prove out designing in a cloud, right? All of our designs, most of our designs in the department are on air-gapped servers in trusted foundries, and those servers, if you want to track the provenance and traceability, if you want to update that design, refresh, it's very difficult to do that when they're on classified servers. So the first objective is to really, how do we design in the cloud, track provenance and traceability, and tap into some of the AI information that companies like Microsoft and Amazon, they have thousands of engineers working on securing the cloud rather than on-prem. You've got a couple folks, right? So that was the first objective. The second is to design a DoD ASIC with assurance, right? So using commercial
Hmm.
best
Hmm. Hmm.
practices for DoD specific designs. How do I tap into the data? And, so it's threats, countermeasures, and residual risk, and fabricate, I believe it was three ASICs or SoCs in commercial foundries using purely commercial lines. Um, there was also another ramp for COTS, for commercial off the shelf. So the NDAA, right, uh, Claire wanted DoD to develop standards. The first draft of those standards is focused on DoD specific parts, but it also has to encompass COTS. So there's a COTS component to ramp that's a separate contract that was awarded actually to Qualcomm, and that's to how do I assure a commercial chip, right? Because if you want to really tap into commercial technology, partnerships with leading fabless semiconductor companies will get you there. The second program is about the foundry, and that's Ramp C. So that's Ramp Commercial. And the objective there is to incentivize an onshore commercial foundry um, with assurance, right? So there's security of the chip, which we call assurance, and then there's supply chain security. So disruption to supply chains when most microelectronics are made offshore is an issue, that
Hmm.
we worry about.
One that we've been experiencing, yeah,
Yeah,
one that we've been experiencing, and
yeah, yes.
yeah.
So Ramp C is three fabless semiconductor companies working with Intel, and to incentivize really an onshore capability. And then the second or the third is SHIP, and that's focused on heterogeneous integration and packaging, which is, for the department, you can take a commercial chip and you can combine it with a chiplet, which is, you can think of it as a small ASIC, and integrate those capabilities. You could have root of trust or what have you in this chiplet, which are much less expensive to manufacture and design. You can integrate that with commercial parts or larger FPGAs, et cetera, without losing any power, performance, and the costs are competitive. So those are the three programs that kind of cover from the design to packaging.
Very good. Yeah, and so I do know. I mean, the DoD is such a small percentage of the total microelectronics consumption. The number that I recall is less than 2%. So it's hard for the DoD to, it's hard to make a business case for just selling to DoD. I think we've seen that. Um, I love the fact that when you set up the program, you basically had that in mind. So how do you incentivize the commercial industry to do things that are supportive of the DoD, but also, well, good for the rest of their sales, good for the rest of their industry. Um, there's been there's a lot written and broadcast about the fact that the premier chip manufacturers today are not in the United States. You know, not too long ago, 60 Minutes did a whole segment on Taiwan Semiconductor Manufacturing Corporation. Um, what sort of a strategic concern does that create? You mentioned supply chain. We always worried about TSMC being not that far off the coast from a major peer competitor. How concerned should we be about that?
So there's a few issues that seem fairly obvious to me. I've taken some basic business school classes as well as
Yeah,
technical classes,
yeah, yeah,
and
yeah.
monopolies in general are bad when you have one company capturing 55 to 60% of the market. um, that's not good for anyone competitively. You have cost issues. You there's two companies that control most of the market, and both of them are not in the United States. I think as a country, um, our leaders in government really need to 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 um, really need to decide, does it matter that the United States could no longer, in the future, let's just fast forward 10 years, does it matter that the United States can no longer manufacture the designs in that our companies sort of lead in right now? And my personal opinion is that it does. It does matter. If you lose the ability to manufacture critical supplies, whether it's bio or pharmaceuticals or N95 masks.
Yeah,
Um,
right, right.
it's a problem, and you can't just stand up a 5 nanometer or 3 nanometer fab, after not being in the game. Like, it's, the old arsenal of democracy, right? Detroit spun up because they had all of the capabilities to manufacture cars that transition to ships and other things. But you can't, once you lose this, it's gone. And to me, I think we should be very worried about that. I don't want to be reliant on other countries for critical anything, right? We should, yeah. I mean, it doesn't. We don't have to manufacture 70%, but we need to have the base to be able to manufacture one, right? And be able to
Yeah,
scale from that.
yeah, absolutely. I also, I mean, the thing that used to drive me, one of many things that used to drive me nuts, when I see we'd wind up having to do end of life
Yes.
buys for chips that were going to cease manufacturing, and we needed them, so we would spend hundreds of millions,
Billions. Hmm.
billions to fill storerooms with stuff that was kind of obsolete. That's why it wasn't being manufactured anymore, so we could stockpile it. And that just, as a taxpayer, that would drive me nuts. Let alone, the principle. Do you see us being able to move away from those if we execute the sorts of approaches that you were advocating and that you put into place?
Yeah, that's a good question, Mark. So neither Ramp C or SHIP address that issue with the lifetime buys. Um, it's never been clear to me, when you can fit thousands of chips on a wafer this big, why we don't just buy more of the components that we need when we're building systems. And the footprint to store those things, if you call it a stockpile, a national stockpile, is small, right? And we know our adversaries are doing this. You can read about Huawei, right? And how they stockpiled components knowing that there was going to be something coming down the road. So it's never been clear to me why we don't have a more thoughtful approach to end of life buys, because the cost is enormous. And then we're also spending a ton of money on technology that's mostly outdated. So there's got to
Yeah,
be a better
yeah,
way.
yeah. Although I would venture the opinion. I think we know why that doesn't make it smart, because we're penny wise and pound
Yes.
foolish. So we save money in the front end, even though it costs us more money at the back end. But I'm thinking the analogy. I think of industries where they do that from the beginning. The automotive
Yes.
industry, they produce a new
Oh
automobile,
yeah.
right? And they lay in the spare
Yeah.
parts.
If you have a German
Uh,
car, I mean, they have parts going back 20 years. Like,
and I'm driving a 22-year-old car which has very very few original parts, and I still have no trouble getting replacement parts for when I
yes.
need them. So why can't the DoD do the same thing? Great question.
Yeah. DoD could learn a lot from automotive. I mean, they really could.
Yeah, yeah. Absolutely, absolutely. So with that in mind, tell us where you think we need to go in the future. I mean, what are the things that what are the next steps that you now that we're both out of the building, and now that we're free to opine without the public affairs people, hooking up the shot collar and telling us what we can't say. Um, where do you think we need to be going?
So assuming Ramsey and Ship are successful, which I've heard, all of those are going extremely well. What is the
Not surprisingly, we've got Brett
yes,
Hamilton running that. Not surprising.
yes. What are the next steps to get all of those advanced components that are going to be coming out of those programs out to existing systems or get them integrated into the designs of new systems, and how do we refresh them out in the field? I'd also, Mark, like to see, there was a national semiconductor leadership strategy, and there's $52 billion that has been authorized in the NDAA. No funding yet, but a strategy. It's not clear to me what problems we are solving. Like, should we be manufacturing here in the United States, and what percentage, and R&D, and all these things. So we need a strategy that the government and commercial industry can get behind. And when I was at the department, I was surprised at how much our commercial companies wanted to partner with the department, and they understand the risks associated with China and with our adversaries as much as we do. And there's a lot of synergy there, and getting a strategy and that the government and industry can partner on, I think is something that's critical to our success.
So, we saw the Artificial Intelligence
Yes.
Commission recently. They released a report. And by the way, they went beyond artificial intelligence and specifically addressed microelectronics, which I was very pleased to see. And now we're seeing the latest National Defense Authorization Act also includes other commissions. How would you like to see that done? Would you want to see a commission set up? Would you want the department to do it internally? What's your
It's a good
recommendation?
question. Any mechanism where government and industry can partner together, and you bring in industry experts to to inform and educate, I think is ideal. There is a gulf that exists. I'm out in Silicon Valley. There's a gulf that exists between the Pentagon and industry, and closing that divide, any mechanism to do that, because the industry is willing to help, um, and really just being able to tap into that is just so valuable.
So a little bit of shameless self-promotion. I think we're going to try to do some of that here at ETI.
Yes.
So yeah, I agree. I think I'm seeing across the board a number of the emerging technology areas that exactly as you say, industry is willing to help and is looking to bridge that gap. And I can't think of a more important area than in this realm. So, Nicole, our time is winding down, and as with most of my podcasts, I feel like I could go on for hours and hours. Fascinating discussion. Obviously, extraordinarily important. Let me just say, absolute pleasure to talk to you about this. Thank you so much for your service. I mean, the things that you did in the Pentagon were, I'll reiterate, were absolutely amazing. I used to say you got more accomplished in 2 years than most people get accomplished in a career in the Pentagon. So it was really a joy to work with you, and I'm glad to see you applying all that knowledge now in industry. And I'm also noting I'm looking at the sunny the scenery behind you, and I'm in freezing Washington D.C. as we record this. So I can see the attraction of the West Coast as well.
Thanks.
So Nicole,
Thank
thank
you,
you again for
Mark.
joining us.
Thank you. Appreciate it.
Sure.